Okay, so we left off last class by concluding that information was the key to determining externalities and externality policy. Assessing externalities requires collecting the right information, and as we discussed, externalities tend to be cases when the information is either diffused among many members of the public or held by an expert who's not one of the parties directly involved. And that's what we're going to talk about today. So some of the relevant information for assessing externalities is scientific, technical, and usually best accessed by experts. And some is subjective and held by dispersed individuals who are directly involved. And this is problematic for policy often because you have to give these individuals an incentive to reveal that information. And today we're going to talk about how to combine these two types of information and the trade-offs between ways of getting them. So we'll start by talking about benefit-cost analysis as an encompassing, as an encompassing framework for this type of analysis. We actually just held a conference on benefit-cost analysis at the law school this past weekend on financial regulation. And then we'll talk about how scientific and technical studies combined with economics play into these types of benefit-cost analyses, focusing on one particular ingredient that comes from economics, which is the statistical value of human life and health. And we'll go through an example of a benefit-cost analysis, probably the most ambitious and famous of these, the Stern Review of the Economics of Climate Change. We'll then talk about useful types of private and subjective information, contingent valuation as a sort of naive first pass to addressing these issues, and then we'll talk about the Vickrey-Clark-Groves mechanism as a way of dealing with the incentive problems that arise in these surveys. Okay. So benefit-cost analysis is a common paradigm for policy evaluation, and it's supported by economists perhaps because it lines up so cleanly with the way that economists think about things. It emphasizes the importance of trade-offs, pros and cons, and is applied to a wide range of decisions like instituting regulations, building public projects, and for our purposes, determining the right level of caps for cap and trade, of externalities for a Pigouvian tax, and of damages for Pigouvian taxes that are assessed through the legal system. So the benefit, I think, of benefit-cost analysis is that it provides a rigorous language to try to make commensurate different dimensions of trade-offs in terms of dollars, basically. And the different dimensions of these trade-offs include direct harms of economic resources, how much resources are destroyed and how much the market values those. Second can be limits on the way in which you can use resources, and again you have to use market prices to assess how valuable different uses of those resources are, and therefore how harmful it is to limit the use away from its most valuable use. Effects on human life and health, which we'll talk more about soon. Intangible harms on subjectively valued resources, which can be determined either inherently from an ethical theory or be derived from how much individuals value those things in terms of their willingness to pay to preserve them. Okay. So benefit-cost analysis is often used to make big public decisions, such as instituting a new regulation on an industry, building a public project in some location. But the same basic methodology applies to determining externalities, such as determining the right level of Pigouvian tax. You need to add up all the marginal external costs and benefits. And it requires considering the same list of factors that we just discussed. Another common application is to assess damages in a court case. So when there's a big lawsuit brought that involves economic damages, often economists are hired to do these analyses. In fact, that's one very common form of consulting by economists. And as we discussed in the last lecture, these damages effectively act as a form of Pigouvian tax. Benefit-cost analysis can also often be used to determine the optimal level of a cap for cap and trade. And in some ways, this is the closest to classic benefit-cost analysis. You determine the best level for such a cap. And often the choice is discretized, so it's almost like making a choice about a project. And these analyses are undertaken by economists or either directly or that are commissioned by courts or hired by bureaucracies in the government. So a crucial element in all of these benefit cost analyses is technical. What are the physical effects that actually follow from some particular action? And this typically requires detailed knowledge of and interaction with, among other disciplines, physicists. So for example, if you're trying to think about the benefits and costs of nuclear power, you need to determine, what are the chances of a nuclear reactor having some disaster? What are the chances of CERN? I don't know if you guys know what CERN is. It's this particle accelerator in Switzerland. And a long time ago, I guess by your standards, but a short time ago by my standards, when you guys were probably in middle school, there was all sorts of debate about whether CERN would blow up the world. Some people said that CERN would tear the universe a new asshole. But that didn't happen. So there was some very, very small probability of that, and you had to assess how large that probability was, right? Chemistry can also be useful. So for example, if you put SO2, sulfur dioxide, into the atmosphere, it can cause acid rain, and chemistry can help us determine how much acid rain and how severe it will cause. Or, it can help us determine if you pollute a lake, what will be the effect on the chemistry of that lake. Epidemiology can help us determine if we vaccinate certain people, how much will that reduce disease in the population more generally. Ecology can help us determine how fish stocks are affected by pollution or by overfishing, or what ecosystem services will be eliminated by deforestation. However, of course, all this stuff is useless unless you have the right economic back end on it, right? So we might be able to tell from physics what's the chance of a nuclear meltdown, but it won't tell us what's the value of the land that will be lost and the lives that will be harmed by the Fukushima, right? How valuable are the crops? We can learn about acid rain and maybe even how many crops they'll destroy. But to actually put a dollar value on that, we need something coming from the market prices, right? Or futures prices or something like that. If we want to know how we should treat the small risk of a catastrophic outcome like the CERN disaster, you need to use the economics of dealing with uncertain outcomes, like concave utilities for risk from expected utility theory, right? If we want to try to value the production we get from more pollution today against the destruction of fish in the future, we need some we need some notion of the discount rate to trade off harms today against values tomorrow. Adam, if we were trying to value ecosystems services, like things that came from the rainforest and that we might lose by destroying that, what are economic factors that might enter into figuring that out?
We can probably look at the past on how it has affected medicine, and then I guess account for the price of
the price of those drugs or the consumer surplus that was associated with those drugs being created, right? Another question that we might ask is, how much are lives or the health ruined by diseases in the epidemiological example worth? And we're going to turn to that in just a minute, talking about the valuation of human life. So almost all of these benefit cost analyses involve some intimate connection of science with economic analysis. And perhaps the most famous input from economics is the value of human life. The reason it's so famous is because it's so controversial, because most people want to say, well, life is just invaluable. There's no way to put a dollar number on life. But of course, this is completely inconsistent with the fact that people drive around in cars which endanger their lives, maybe with small probability, but not that small probability, in exchange for all sorts of other benefits they get, right? So, when people make decisions, they do make trade-offs. They take their life into their own hands. They make trade-offs between their life and other benefits they can get. And when the government makes decisions, it has to do the same thing. It just has no choice, right? And in particular, the wealthy have a lot more money to spend on trying to preserve their lives. And we know that wealthier people get better health care, they do all sorts of things. So that means that they must, in dollar terms, put a greater value on their life than poor people do. And so if the government wants to make consistent decisions, it's going to have to do the same thing. So that leads to the conclusion that a rich person's life is worth more than a poor person's in dollars, which may seem unjust, but you just have to think about this is one of the many things that money buys. Money buys you a better house, buys you a nicer car, and it buys you the government putting a greater weight on your survival than a poor person's survival, right? Now, of course, you could redistribute money so that the poor people can have more of everything that they want, but not allowing people to make trade-offs between the weight put on their life in social calculations and other things that they want would just be inefficient, right? The poor would not want, they would rather have a little bit less weight put on preserving their life and a little bit more house or TV or car, and it would be inefficient not to allow people to make those trade-offs. Yeah, Mike?
Could you explain more why, like the fact that rich people can spend more money on things like healthcare, like quality of life or whatever, means that governments value their lives more when they do policy?
Well, government has to value their life more or it would be inconsistent, right? Those rich people are willing to pay more in order to have their life preserved. So it would be inefficient for the government not to put a greater weight on preserving their lives, because the government can make everyone better off by putting a greater weight on preserving those rich people's lives and then taxing those rich people for it, right? Because they value... Okay, so imagine that we had two policies. One that could, with some small probability, kill a rich person, or one that would, the same probability, could kill a poor person. Clearly, it's better to implement the policy that would kill the poor person. Why is that? Because you could tax the rich person and redistribute to the poor person, and everyone would be better off. Because the poor person isn't willing to pay as much to reduce that chance of preserving their life, and the rich person is willing to pay more, right? So it would just be silly as social policy to say poor people have to have cars that are ugly, live in houses that are falling down, get education that's bad for their kids, but they get to have exactly the same amount of weight put on them in public decisions about health, right? That just wouldn't make any sense. Yeah, Philip.
Has the fact that rich people also contribute a lot of tax dollars with their labor and thus losing a rich worker would be more harmful to the government than losing a poor worker been also weighed in on this?
Yeah, so that also should be taken into account, and in fact, that's a good point. That's a reason why actually the responsiveness of, that's actually a very good point. So what we're going to see is that the elasticity of life with respect to income is approximately, is going to be less than 1. But one reason that might be the case is because the government is taking some of the money. And if the government's taking some of the money, then the government should care more than the individuals themselves care about preserving their lives. Yeah, Mike?
What about policies that, like in preventing like an epidemic or something, do more for lower income people because rich people like have insurance or like things like that would keep them, or like lower income people live in closer proximity to each other in some cases, so like diseases are more likely to spread. How do those calculuses factor?
I mean, I think that in general you just have to value people's lives as they value them themselves in dollars.
Okay.
I mean, I think that's the only efficient policy. Yeah, Austin.
Going off of that, how is like prospect theory and other behavioral corrections, I guess, worked into these prospects?
So, in fact, the origin of a lot of behavioral stuff was studies of these types of things where they found that there was inconsistencies depending on how you framed the questions. And, I think you get pretty sensible numbers out of these analyses. Despite all the problems we'll discuss with them. I think that's one problem, but I think there's many other problems associated with these analyses that we'll go through. But, yeah, Julian.
So is this analysis of, does this still hold even if you don't redistribute wealth? Because it seems like most public policies, at least that I'm aware of, don't do the kind of like here's how much benefits, so we'll tax them by that amount.
No, it doesn't require you to really redistribute the wealth, because the truth is that like we choose the tax system and the amount of redistribution that we do to like roughly trade off the benefits of redistribution against the costs of reducing like the amount that people work, right? And as long as you're doing that trade-off correctly, then the value of $1 to a rich person from a society's perspective and the value of $1 to a poor person should be equal. Otherwise, you're not doing that trade-off correctly, right? So in other words, like the reason why, even though inherently the value to $1 to a poor person is greater, the thing is that giving it to the rich person also leads people to work harder to try to become that rich person, and therefore generates more taxes for society that it can redistribute to the poor. And as a result of that, those things should like balance out. Yeah, Joan.
Shouldn't the value be calculated based on willingness to pay, not how much they can pay? Because
No, it is willingness to pay. That's the idea.
but if you ask a rich person and a poor person how much they're willing to pay to save their life, they'll probably say the same amount. But how much?
Well, if you ask them, but like what willingness to pay is how much you are actually willing to pay, like out of the income that you could have for your lifetime.
Right. So that's how much you can pay, right? Not how much you're willing to pay.
Well, I don't think that that's true, because the truth is that like that would be true if everyone would be willing to pay their full lifetime income to preserve their life. But that's not true. Like most people, in order to reduce by 1% the chance that they die, are only willing to pay a few $100,000, not all their lifetime wealth. So if everyone was like running up against their lifetime budget constraint, what you're saying might be true, but that's not the case. Yeah, Tanner.
So, can we think of this as like payment in accordance with product, that the rich person can afford to pay more for it, so their life is worth more?
Well, Becker would say that, but I'm not sure I would say that. Like, I think this is a distributive question, not a question of, like, it's a question of efficiency to make sure that you, like, equate these things in terms of, like, given someone's wealth, what they get. But I don't think that it's that they're being... the reason that the rich person is making more money is because they have greater endowments. We could redistribute those endowments from them, but we talked about all the problems with doing that. So given all those problems with doing that, this is the best that we can achieve and still be efficient. Yeah, Philip.
If you take into account a typical discounting rate, then does the value of like the statistical life, does someone seem lower than their lifetime income? Because from what I've been seeing,
Yeah.
the VSL numbers tossed around, they seem to be quite a bit more than at least a lot of the people on the lower end of the income distribution actually do make in their lives.
I think it's pretty comparable with it, but I agree with you.
Okay.
Someone who makes $50,000 a year, plus they're going to get some amount in government benefits in some sense, times 20, which is roughly, that should be about $1 million. And people are willing to pay about 5 times that to preserve their lives at that income. So, yeah, that is valuing it more. But, okay, so there are 3 categories of things that need to be measured for this purposes. One is the statistical value of a life for someone at some income level. The second is the value of other types of injuries, like diseases and so forth. And then you need to extrapolate this to other income levels using some income elasticity. This is usually calculated to be about 0.6 or 0.8, though as Philip said, this should really be in some sense as a function of their post-tax income rather than their pre-tax income, because the government is taking some of their income, and you want the government to value that part that they're taking greater as well. Okay. Yeah, Philip.
Just to be clear,
Yeah.
those numbers up there are for pre-tax income, elasticity with respect to pre-tax.
I think so, but I'm not completely sure.
Okay.
I'm not completely sure. Okay, so the usual approach to measuring this is to assume that the value is on the life that is like that you die or live, and the value that you place has nothing to do with the way in which you die, right? That's a crucial assumption, and it's the basis of all the numbers we'll see, though it's not all that realistic, because if you really don't want to die by fire, but you're happy to die by ice, then you should obviously not have the same willingness to pay to avoid those two types of death. And the way that these things work is to look for cases where people have made trade-offs between these things, like they're deciding whether to take dangerous work like mining or a safer job that's like along other dimensions similar, or they're deciding whether to purchase a safe or an unsafe car that are otherwise different. And you look at the price differences as a measure of willingness to pay, and that measures the willingness to pay of the marginal person who's just indifferent between these two choices. You then treat everyone as if they're exactly the same as this marginal person. Now, you can immediately see why this is so problematic. Imagine that the cost of a safety measure on a car starts really high and gets low over time. This would work if there was one price at which suddenly everyone adopted that innovation. But in reality, as you improve safety, people are going to gradually move into buying this car, right? And if that's the case, then the marginal person is not going to be just representative of the whole population, and we're going to get different numbers for this as the price of this innovation comes down, which seems pretty problematic, right? In particular, if it were really true that everyone had the same value on their life, then you could only get people to be indifferent to taking this job at one particular price. And we know that's almost certainly not the case. That as the wages move or the prices move, different numbers of people will do it. It's not like it just suddenly jumps. And that makes all this stuff somewhat suspect. So, however, I think that what's beneficial about these numbers is they give you at least a rough order of magnitude sense that can be used in government calculations. Now, you can also try to get more individually at this by trying to use surveys to get people, like Joan was suggesting, to say how much they're willing to pay. But for the reasons I was talking about with Joan, and we'll talk about a lot more, that's a pretty problematic process. Okay, so let's take a sample version of how one of these statistical life calculations works. So imagine that every year, 3 of 2,000 coal miners working in a particular coal mine die. And suppose that factory workers have comparable skills and the jobs are comparably pleasant, but that only 1 in every 2,000 factory workers dies each year. And suppose that the coal mining company pays $4,000 more a year, and assume that this is the only relevant difference between the jobs. Well, then the difference in the chance of dying is 1 over 1,000. And in exchange for this, you get $4,000, and so the value of your life to you would then be $4 million. Okay. So the real calculations are no more than detailed econometric versions of these same calculations. And to calculate income elasticities, all you do is you look for a rich man's version of a coal mine, whatever that is. Okay, so here's a bunch of studies that have looked at this. They tend to find that statistical value of life is somewhere between $1 and $10 million for someone earning median U.S. income, something like that. Though this is a little bit dated, so my guess it's a little bit more in present dollars. It's probably closer to $10 to $15 million. Okay, so perhaps the most ambitious... Oh yeah, do you have a question?
Yeah, sorry, in the previous slide,
Yeah.
when you said, suppose the coal mining is $4,000 more.
Yeah.
That's the coal mining, so that's the company's cost for reducing the worker risk, right? What is
No, that's how much more they have to pay in order to get people to work at the coal mine and accept the loss. You see what I mean?
Okay.
Okay. So perhaps the most ambitious benefit cost analysis of all time was the Stern Review of the Economics of Climate Change, which was commissioned by the British government along with other people and wanted to evaluate the economic benefits and costs associated with climate change. And it did this in many stages. And Matthias, is Matthias here? No. He dropped. Anybody else want to talk about what the Stern Review did in order to analyze this? Okay. So it did basically 4 things. So the first thing it did was to determine the largest sources of greenhouse gases. And Tanner, what did those turn out to be?
Turn to be carbon emissions from energy production, animals, methane.
Animals are a surprisingly large source. That's right. So, so animals have, like a lot of cow farts basically account for a large fraction of all global warming. But also energy from carbon from energy, deforestation, reducing the amount of carbon absorbed, etc. Second, they had to determine the effects that these had on the climate. Wesley, how does that work? What are the effects of greenhouse gases on the climate?
Well, the larger emissions, the more the temperature is going to rise, and there's a runaway effect. So if we don't reduce the emissions enough, then it'll still keep rising, even though we reduce the emissions.
Yeah.
So there's a critical level. It's like 80% less than what it is now, at which we could stabilize it. But we have to reduce it a lot.
And all those things are based on these climate models that are filled with uncertainty, right? And so what you really get is a distribution of potential outcomes conditional on actions you take rather than a final outcome. So what Wesley is saying is a little bit like the example we went through where, the firms enter at some particular price, but we don't know what that price is, and so it really looks smooth. So even though he's right that, the climate, there's probably some point beyond which we go when things really go to hell, we actually really don't have a very clear sense of what that point is. And so in reality, it's much more smooth than it sounds. Then you have to try to determine the economic effects of climate change. Rishi, what were the primary economic impacts of climate change that they determined?
One was that resources are obviously being affected, so land costs. Say if land costs are driven out to be very different, then people are obviously going to suffer different. Another one was the forests were being harmed. So what is the word?
Yeah, that's right. I mean, I think the biggest one is probably farmland, is harmed, and that makes agricultural production lower. So that's an important thing. Then they had to try to determine the extent to which adaptation to climate change. Oh yeah, go ahead.
Didn't they also say that one of the economic effects is sort of this disproportionate, unfair effects of climate change being on the poorer countries, which didn't contribute to it at all? So
yeah, though that should, from our perspective, of this analysis, actually mean that should be counted less. Right, because they're poor and they can't afford to.
Well, in there, didn't it say that they would be affected by it most severely and most quickly?
Yeah, and I think that, I know it sounds unfair,
they're not
but
responsible for it, but they're paying the price for it, and that being the externality, isn't that part of it?
yeah, I mean that's, it doesn't sound like a very good thing, but if it was happening to rich people, it would get more weight if you were doing a standard benefit cost analysis. So then, yeah, Mike.
I guess, is there a way of incorporating ethics into analysis? It's subjective, yeah, but I feel like, especially, and it shows in the summary of the report that they clearly believe that it's unfair that these kinds of things that are created by developed countries are disproportionately affecting not so developed ones.
Yeah.
So is there a way of accounting for those kinds of things, or changing the calculus of what we should?
Yeah, I mean, look, you can incorporate all sorts of other things in if you want, but they have the consequence that you're not going to get something that's proto-efficient. The most efficient thing to do is for us to, weight things in the way that we're weighting them, and then compensate the poor countries. The poor countries would be happier for us not to worry about killing them, but to give them money, because they're going to die from disease or starvation long before they die from climate change. I mean, I know that it sounds brutal and whatever, but just think about the logic of it. It's you're taking people who have life expectancy of 25 years because we don't give a goddamn about them. We just let them all starve and die from malaria. And then we worry about that in 70 years they might have rising sea levels. Like, how is that generous and ethical? Yeah, Austin.
Didn't Larry Summers get in trouble for an email along these lines?
Yeah, I may get in trouble for saying all these things to you. So then we need to determine the extent to which people adapting to the climate change can mitigate its harmful effects. And Florence, what are some of the ways people might adapt to climate change to reduce its harmful effects?
You could change to different technologies and reduce emissions that way.
Well, but that's reducing.
Oh, right.
But how could they adapt to the changing climate? Well, they could move out of New York City to Chicago, right? Because Chicago probably won't be flooded, and New York probably will. But the problem I think we have is that we don't have institutions that do a very good job achieving the incentives to migrate. So for example, a lot of people, like when there's a flood in like New Orleans, they all get bailed out by the government rather than people being forced to buy flood insurance. Though increasingly, the New York Times is writing about this, they've been forcing people to buy more flood insurance, and a lot of people are being forced to move away from the areas, and that could be very useful in adaptation. So how much of that occurs is really important. And there's an interesting study by Rick Hornbeck that looked at the Dust Bowl in Oklahoma when all the people were forced to move out, and tried to look at how well people adapted to that and how that mitigated or did not mitigate the effects. Now, Mitch, there are some other impacts that climate change can that carbon can have other than just directly on climate change. Do you remember what some of those were?
Ecologically speaking, it can have changes in animals and environments. It can change pH levels in waters. It can create high average temperature per year rises.
Yeah, so it can salinify and acidify the ocean, right? And it can affect ecosystems by causing certain things to be able to grow and others not. So those were also tried to take into account. Now, corresponding to the cap and trade versus the Pigouvian tax paradigm, there were two different analyses that were part of the Stern report. And Mike Fosco, do you remember what those two analyses they did were?
That there's a huge amount of uncertainty about where they can cap this. That they know that they have to stabilize it between like 450 and 550. So I think they were going with the cap, so then you can know because you're not entirely sure of like the price that would need you to do that.
Yeah, so they did two different analyses. One was they tried to say at the business as usual scenario, what is the marginal cost of an additional ton of carbon, to try to determine like an optimal tax or something like that. And then they also tried to calculate what would be the optimal amount of carbon. So the benefit of this approach is that you don't need to do anything to estimate the technology that will be arised and the costs of mitigation. So it's simpler. But the drawback is that there might be highly nonlinear effects of carbon, like Wesley was talking about, that might lead to some very catastrophic effects, and this tax really might not do a good job capturing that, right? Their estimate that they came out with was $85 per ton. Now, the socially optimal level of carbon for that calculation, they try to deal with the nonlinearities and try to figure out beyond what point it might be very dangerous. The drawbacks is this requires you to have a very good understanding of the technologies that are available for mitigation to weigh those against the costs. And they argued that we should try to stabilize carbon at 450 to 550 parts per million, though we're jetting past that at the moment. So I don't think it's very likely that we'll achieve this goal. This review is quite old by now, I guess, right? Do you guys remember when the Stern Review first came out? You guys were probably in middle school or something like that, right? Probably even before that, I would guess. I don't know, I'm not sure. Maybe 2006. So I think what's most interesting about the Stern report is that it illustrates how hard these types of things are. like one example of this is that many of the worst costs from climate change come from the possibility that there's some very extreme disaster that climate change causes. And if we have a technology such as geoengineering, like putting chemicals into the atmosphere or into the ocean that would absorb a lot of carbon or reflect a lot of sunlight, that can eliminate the worst possible outcomes, this can dramatically reduce the costs, not because those things aren't harmful and bad, but because they're not as harmful and bad as like the most dire scenarios, which in the end account for most of the costs. And so it's, yeah. So whether or not we think we would end up developing and using those technologies could make a huge difference for whether it makes sense to invest in reducing carbon today. Okay. Now the Stern Review focused on sort of hard economic costs, and it leaves out a whole bunch of other stuff that is clearly pretty relevant. So for example, do people like it being warmer or cooler with rain or less rain or whatever? Now this might sound frivolous relative to like, swallowing up whole continents. But if you look at the difference in real estate prices between here and Palo Alto, you'll realize that the weather makes a pretty huge difference to how much people value living in a place, right? And, there's a question of how you might quantify this in an objective fashion by using real estate prices, which maybe they could have taken into account, but they didn't. Yeah, Tavish.
What if like California then just becomes a desert?
Well, that would be a harm. So you'd have to take that all into account. Yeah, Bart.
Didn't like Kahneman show that people who live in like Michigan and like California are like equally happy?
Yeah. So the question is whether you believe or not believe the happiness numbers versus the prices. I don't know. There's a lot of debate over those things. I mean, I think even Kahneman is a little bit less confident now that happiness is the right measure for this stuff. So, another question is, how much do people care about the animals that get killed by climate change, right? And, to quantify this in an objective fashion, you need to use something like, how does the government make decisions about killing animals in other contexts? What are they willing to pay to preserve those animals? Yeah, go ahead, Austin.
So, how does the second point play in with like quantity invariance? It's like John List demonstrated, it doesn't matter how many animals are being saved. It's pretty much $20 no matter what.
Well, we'll talk about the problems with the surveys in a moment. But I think that in principle you could be more quantitative about this. I'm talking about how you would, figure these out in a purely objective way using a scientist rather than. Another question that would be difficult is imagine that this is going to destroy some civilizations, right? The question is, how do you put a value on cultural preservation? That's tough. Another issue might be that individual people out there in the population might know information that the government doesn't know about how costly it is for them to cope with acid rain and things like that. And as we talked about, Hayek said it's really important to get information from the individuals who actually know about what's going on. And if we ignore that in these analyses and only rely on experts, we might get a much less compelling estimate of the benefits. And because, for basically all of these things, it becomes important not just to know what market prices tell us, but also to know what are people's personal subjective valuations for various things. And this is true for a wide range of things. When there are subjective existence values, such as the value of environment, of culture, of the place, of still living in the place where you grew up, right? When there's local information about technologies or impacts, when you're thinking about health or life and not just trying to measure the value of the marginal people, but of inframarginal people, whenever there's local information about technologies or impacts, like a farmer may know that his farm is particularly dry, or a New Yorker may know that he's subject to flood risk because of particular properties of his house, right? So I think the question in these things is always to look at it as an issue of information. Not just to say that we inherently need to go to people in order to get this information, but to ask, are there really concrete pieces of information that we think that the public might know, that the government might not be able to figure out using some more objective method, right? That is, it's not the value to individuals that defines what we care about. It's really that there may be information that individuals have which is particularly important. So for example, if you try to figure out how much should we value the preservation of cultures, there's a natural question of whether this comes from how much individuals value them or how much we as a society should value them. And what is it that individuals value about them? So for example, imagine the reason why we value preserving some cultures is that they may have a language which, even though we can't currently understand it, holds the key to understanding the history of human language, right? Now, it would be pretty stupid to go around to people and ask them, how much do you value preserving the whatever culture? Because they would have no idea that this culture happened to have that language or not, right? Instead, people might have some information about how much they value learning about the history of the world that the government doesn't have. But the person who has the information about whether this tribe holds the key to the history of the world is not going to be the individuals in the public, but some anthropologist who's an expert on this, right? So you always want to ask yourself, who has what relevant information and how do I relevantly combine it? Not just assume that whatever people say must be the correct number. Okay. So when we do need such information, when we really do need to learn from people how much they value preserving a culture or some environmental feature that they can understand, a natural approach is to just ask people how much they value it. And what is that approach called, Tanner?
Contingent valuation.
Yeah, exactly. So this is a very simple approach that has a long history. And what you do is you basically describe different scenarios to people, and you ask individuals how much they'd be willing to pay to have one scenario over another. That's why it's called contingent valuation, because you're valuing the contingency that something gets destroyed or preserved. And you impute from this, you assume that this represents their true willingness to pay. This is most commonly used for environmental issues, but also for creating transportation or other public goods. Okay, so Kim? What are some examples of areas where contingent valuation surveys have been used?
Value of historical place.
What?
Value of historical place.
Yeah, absolutely. Can you think of any concrete example?
The Royal Palace.
Yeah, that would be good. Another very famous one is preserving visibility of the Grand Canyon. Like someone might say, oh, someone's going to build a hotel, but it's going to obstruct your ability to see the Grand Canyon. How much would you value, given the chance that your kids might go and see it, like being able to go visit the Grand Canyon? Or payments to preserve seals or whales in the ocean, to avoid logging in national forests, the value of the birds killed by the Exxon Valdez spill, the value of preserving languages of an indigenous culture or building a new city. And these are real examples that have been commissioned by regulatory agencies or courts. And they're very common in the benefit cost analyses of externalities, regulations, and actions. They can also be used to assess damages from oil spills. And most of these are formal money-based surveys. You ask people, how much are you willing to pay, how many dollars? But there are also some informal forms of this, such as surveys of public opinion by politicians often influence the actions those politicians take. And because they're not actually calibrated, you don't actually say how many dollars, they're not the same as contingent valuations, but they have significant similarities and impact policy in somewhat similar ways. Now, these types of surveys are held in very low repute by economists. Why is that, Adam?
Well, some of the examples that the study used was for example, getting a warm glow.
Yeah.
The idea of feeling good that we value these things. Also, you could kind of use it as a political issue, a 0 or really high number to bump up whatever the average is.
Yeah.
Or just you're not an expert on the matter and have no clue.
No, those are all really good points. So I think the leading point is just people don't take these things all this seriously. Imagine someone came to you and was like, how much are you willing to pay to preserve the seals in the ocean? You would say, I don't care. You'll just say whatever sounds fun to say. You know what I mean? The second thing is people often answer the wrong question. They don't say how much they personally would be willing to pay, but how much society as a whole should be willing to pay, right? And that, if you add it up over all people in society, leads to way, way too high of a number, right? People, even if you could ask them, usually don't have any idea, information, or experience with the question you're asking them. They may not even have heard of the species of bird that you're asking them about or the culture that you're talking about, right? People are often motivated just to feel good about the answers that they give. So like, if you ask them about something really politically sensitive, they'll say it's like a huge amount. Like, if, how much would you be willing to pay to stop pollution being dumped on like poor people in Africa? Because that sounds really sensitive. People might say some huge amount, even though they would never actually pay anything like that, right? And a sign of this is people's responses are highly inconsistent and apparently irrational. They can differ by orders of magnitude, or just depending on how you frame the question, or as Austin was saying, they can be completely invariant to quantities. And perhaps the leading problem is that people have no incentive to get things right and no experience that would allow people to get things right. Yeah, Dave.
Have there ever been any cases in which people have actually asked for donations and actually got monetary contributions?
Well, that doesn't work either because that suffers from the free rider problem.
Oh, okay.
So the only mechanism that solves this, well, we'll talk about the Vickery-Clark-Groves mechanism. As you'll see, that's pretty problematic. The only mechanism that really solves this is quadratic voting. And in fact, one thing that we're trying to do is set up with the company is to try to replace contingent valuation surveys with quadratic voting based surveys where you're actually forced to make trade-offs between allocating money to things and, yeah.
I don't know whether this is like a misapplication of an economic concept, but supposing that we could get people to answer the questions accurately and not motivated by one or whatever, is it still worth trying to make sense of the answers? Because I was thinking of like Arrow's impossibility theorem, that there's no rational way to aggregate all the preferences and all the wants of these individuals.
So
creating a good social...
Again, we'll talk about quadratic voting at the end, but that violates Arrow's impossibility theorem. So you're right, given like existing ideas about this problem, there's supposed to be like no solution to this problem, but I don't think that's true. So, yeah.
I feel like it might be mentioned here, but isn't the fact that they're probably not actually paying directly for whatever cause they're...
Yeah, that's sort of what Dake was saying, right? He was saying that like you're not actually forcing people to make trade-offs. So, yeah. Yeah, Philip?
Arrow's impossibility theorem only says that purely rank-based things don't work.
So that's exactly the reason why QV
isn't ruled out.
Exactly. Yeah, exactly. Okay, so let's talk about the strategic problem because I think it's like the biggest problem at the heart of what's wrong with contingent valuation. What your incentives are in a contingent valuation survey depend on what it's being used for, right? So imagine that no one is going to take this survey seriously at all, right? People are just doing it for fun or for research or whatever, right? Then, Maury, what would be your incentives in a contingent valuation survey? If you were responding to one and you thought this was just going to be used for research or no one would really care what the answers were?
What would be my incentives to fill out the survey?
Yeah, what would be your incentive to report?
I wouldn't have any. I would,
You would do whatever was sort of fun or, whatever entertained you or sort of pissed off the survey guy or pleased the survey guy, depending on whether it's a good-looking member of the opposite sex or some nerdy person, and that's probably true right now because a lot of these things people don't take seriously because they're totally stupid. But what if the survey actually did have a major impact on public policy? Austin, what then would be your incentives in filling out the survey?
Well, you would have an incentive in the sense of actually being able to influence public policy.
And what would be the right thing for you to report?
Oh, the most extreme version of what you believe.
Yeah, exactly. Right? So in this case, you have huge incentives. So if you like the Dolphins, you'd say, I think I'd be willing to pay, I don't know, $7 trillion to preserve the Dolphins. And if you, imagine that you were a worker on the Keystone XL pipeline, right? And they asked, how much are you willing to pay to preserve the right of like the caribou to go across the plains of Montana or whatever, and you would probably say 0, right? Or negative, because you want to make sure that they don't block the Keystone XL pipeline in order to, save the caribou, right? So you never have an incentive to report truthfully. And a great example of this is a story from The Economist. So did I tell you guys this story yet? No.
He was on the syllabus.
Oh, it was, yeah. So there was this great story where The Economist went around Haiti, and it asked people, have you been receiving supplies from UNESCO? And people said, oh, no, we haven't gotten anything. And they went around to people's houses, and they saw these stacks of like UN, boxes filled with food. And they said, why did you lie to us? And they said, well, if you knew that we were getting food, we wouldn't get any more, right? So if we want to take seriously how do we get people to report, we need to consider the incentives that this gives people, right? And suppose we know, let's go back to the analysis of externalities we did from previous class. Suppose we all know all the benefits associated with a particular project, and or a particular thing like pollution, and we're trying to determine the socially optimal amount, but everybody knows the amount that they individually are harmed. So there's dispersed information about this, right? Then the total harm is just the sum of the individual harms, right? And the question is, how do we get people to tell the truth about the harms that accrue to them? Maury, how did your reading say that we can do that?
Well, they would ask you to report like the utility you got, and then
Yep.
they would pay you all the other people's utilities except for yourself.
Yeah.
They would pay you that amount of money, and that would incentivize you to tell the truth.
Exactly. So that's sort of an approach that pushes this whole thing back a layer. It says, how do we figure out what externalities are? Well, we make everyone pay their externality associated with saying that their externalities are a certain thing, right? That's paying everybody else's utility, right? So then I report, because the thing is, reporting a harm to the system, because it influences a social decision, is really just like taking an action. And if I pay the externality of that action, I'll want to do what is best for society, right? So Mike Galperin, what's the externalities of reporting that your harm is some amount?
It would be like the benefit you get minus the harm on other people.
Well, the benefit you get, you capture yourself, so it's just the harm on other people. But the question is, why does it create a harm on other people if you report your harm to be a certain amount?
Because if you report, because the utility that you report affects the payouts to other people under the system.
Well, it affects the amount of the action that we take, right?
Right.
And once you change the amount of the action you take, it harms or benefits other people, right? So the reason is because without me, society would maximize welfare without looking out for my interests. And with me, society also has to care about my interests. And so my externality is how much other people could have achieved if they didn't have to worry about me, minus how much they achieve when they do have to worry about me. Okay, so let's return to the smoking example and imagine that it's a small room now. And the value of smoking to one smoker is 100s minus s squared. And there are two people who are each harmed in amount s squared plus 5s. And then you are harmed in amount s squared plus 10s. So the question is, Adam, what would be the optimal amount of smoking if I wasn't in the room?
Would be the marginal cost, or the marginal benefit to the smoker should be it would be 15.
Okay, so the marginal benefit to the smoker, right, is 100 minus 2s. The marginal cost to each of the non-smokers is 2s plus 5.
So that would be 4s plus
Yep.
together. So,
Yeah, so exactly. So it's 4s plus 10, and then you set that equal to 100 minus 2s, and you get s squared equals 15. Now the question is, what's the optimum including you, Mitch? What would be the optimal amount if we include the harm that accrues to you as well?
Sorry, I wasn't following.
What is the optimal amount? Okay, so the smoker gets benefit 100s minus s squared from smoking, and each of the two other non-smokers get this harm, and you get a harm s squared plus 10s from smoking taking place. So if we take into account your utility as well as the other people's, what would be the optimal amount of smoking? Sending the marginal benefits to all people in society to the marginal costs. You want to pass on this? Yeah. So somebody else want to try it? Yeah, Dave.
It would be s equals 10 because you would take the derivative of
Yep.
your marginal utility, which is, or harm, which is 2s plus 10.
Yeah.
And then you add that to the marginal harm of the other two people.
Yeah.
So that's 6x s plus 20 in total is equal to 100s. Or sorry, 100 minus 2s.
8s.
Or
Yeah.
yeah, 8s. Sorry.
8s plus
8s equal
is equal to
80.
80 exactly. Yeah. So then, Bharat, can you figure out what the externality is that you create on other people?
So would it be 5 times marginal cost, or?
Okay, so the question is, how much welfare would people have gotten if they had been able to smoke 15? So that's just the total benefit to the smoker if they'd smoke 15 minus the total cost to the other two guys. Right, you can do it on the board, or on, I guess you're going to do it in a calculator.
I got 675. Oh.
No, it's 75. So if the net harm to everybody else is net benefit to everybody else is proportional to 90s minus 3s squared. Sorry, minus 90s minus, I guess this should be multiplied by 3, no?
I just added up the totals. I also get 75.
You get 75.
Yeah.
You have 2s squared minus s squared, so you should have just s squared, which is...
Oh.
No, it's because the lower one is negative, so it should be minus 3s squared.
Yeah, it should be minus 3s squared, right? So this should be 90 times 15 minus 3 times 15. And then we have to minus however much value is created afterwards, which is 90 times 10, and then plus, because minus again, so times 3 times 10. So can anyone do that? Does it give still 75?
$45 minus 375, which is should be negative 335, I think.
I'm going to get up Excel and try to do it
They're
there.
a really large number. What do you get? And 2775.
90 times 15 plus 3 times 15 squared minus 90 times 10 plus 3 times 10 squared. 1425. Woo! Totally wrong. Can't believe I've been having this thing going for 3 years and we didn't figure that out before. Okay, so 1425 is the loss that you create. But you're glad to pay that. Why are you glad to pay that 1425?
Wait, sorry, can you
I think
explain
you added 3 times 15 squared.
It's 75 seems way more credible to me.
Yeah, you added 3.
75. It actually was right. How the heck did that happen? Okay, it was actually 75. What do you know? Okay, so why are you willing to pay that? So imagine that you pay your externality, right? As we said under VCG. Why are you willing to pay that? Well, because you're going to save an amount which is equal to 15 squared times plus 10 times 15 minus how much smoking happens afterwards, which turns out to be equal to 125. Okay, so why did it have to be that way? Well, it had to be that way because society was maximizing the total sum of everyone's utility, given what you report. And you had to pay everybody else's loss. So once you add up everybody else's loss plus your gain, either society's not going to move the amount, right? Or you're going to gain more than everybody else loses because it's maximizing the total welfare, right? And so once you're forced to pay the harm you cause everyone else, you'll always want to tell the truth because your interests are aligned with society's. It's really the same principle of payments in accordance with product that we've been studying before, right? Now, you can look at what this thing was visually. So imagine that this is the benefit to everyone else. Let's just say it's flat. I mean, before we had it being downward sloping, but let's just say it's flat. And imagine the cost to everybody else is this, the cost to you is this, then the cost to society is this. The harm that you create for everybody else is that you move from this point, which was optimal for them, to this point, which is optimal, including you. And that creates a deadweight loss on everybody else of this Harburger triangle here. Now notice that that triangle, as all triangles, is proportional to the square of the length by which it moves, right? That's the reason why quadratic voting is quadratic. Because the externality that you create on everybody else is proportional to the square of the amount that you influence the decision. Okay. Now the most common application of this in practice is the second price auction. Does anyone want to describe what the second price auction is to me and say why it's an example of this? Yeah, Rishi.
Because the second price auction is, whereas a conventional auction is where, if you have two people bidding, the first person ends up paying what the second person pays plus slightly more. In a second price auction, I think the first person pays what the second person bid. Right, so.
Yeah, so in a traditional auction, people bid and you pay whatever it is that you bid. But here you don't pay what you bid. You pay what the second highest person bid. Right? That's why it's called the second price auction. So suppose everyone bids for an object. If the winner pays the bid of the second highest, that's his externality. Can anyone figure out why that's his externality? Yeah, Wesley.
So that's the amount that the second person would have valued the object. And so by you getting it and them not getting it, that's how much you cause them to lose.
Exactly right. Yeah. Now, you always want to bid how much it's worth to you. So let's see why that's the case. Conditional on you winning or losing, you don't affect how much you pay by changing how much you bid, right? So the only thing you can affect is whether you win or not. And the question is, would you ever want to lose by bidding below what you value it at, or would you ever want to win by bidding above? Well, no. Why? Imagine that you bid a little bit below, what you value it at, and someone ends up bidding in between what you value it at and what you've bid. Then you lose, even though you could have gotten it for a price that was below what you valued it at. Now imagine that you bid above, and someone bids in between what you bid and what you value it at. Then you end up winning it, but you have to pay more than it's worth to you.
And you cause them losing more than they were.
Yeah, exactly. So that's the second price auction, and sometimes a more general version of this is used for what's called package auctions. Imagine you have a bunch of different goods, and you could get different combinations of them. You could submit bids for all different packages, and then what you're forced to pay is, so they choose the arrangement, the awarding of goods that maximizes the total amount of bid that they got, right? And then they make people pay how much, if they hadn't bid, would have been created as value otherwise, minus how much value was created, right? And that's basically the generalization of this notion of second price auction. You could also use this in course selection. So imagine that you were trying to choose courses. You could put in bids for all of the different courses that you could get. And then you could have some artificial currency, and you could be forced to pay however much you would otherwise have bid, right? Now, there are many proposals to use this mechanism, but it's very uncommon in practice for a number of reasons. Let me give you one sort of creative example to use this. So, eminent domain is a process where the government comes in and takes people's land and then pays them whatever it thinks is a fair compensation for that. Imagine you had a system where someone had to make an offer for how much they're willing to pay to get the whole package of land if they want to redevelop it, and each person there has to say how much the land's worth to them. And then, if the offer is greater than the sum of the values that people have for their lands, the land gets sold off to the guy. And then if anyone had caused the sale to go a different way, they're forced to pay however much it was worth to everybody else to go the other way. So for example, the person who bids for it, if he wins, he has to pay the sum of the values of the people. And if anybody bids high enough so that it would have been sold had he not bid, but given that he bid it doesn't get sold, he has to pay the amount by which in total everybody else would have benefited. Now this mechanism VCG is very elegant and kind of interesting, but it has a huge number of problems. We're going to talk a lot more about these in the last class, but let me just raise a couple of them now. So one problem that it has is that the money that gets raised has to be given not back to the people who participated, but to some like central government authority or to some third party. Why is that? Well, otherwise, each of the individuals would have an incentive to bid in a way that would make other people be forced to pay more. So for example, imagine that I thought I were going to lose an auction, but that you took the proceeds from the auction and gave it back to me. I'd have an incentive to raise my bid just to get the other guy to pay more so that I would get some of that money back, right? So that money has to basically go outside of the system or be destroyed in order for the system to work, which is pretty problematic, right? Because even though it might get the efficient outcome, you're going to waste a huge amount. A second big problem with VCG, probably the bigger problem, is in these collective decision settings, it's incredibly susceptible to manipulation. Imagine we were deciding what day to have the final exam for the course. And imagine there were two choices of days. I could go through the audience and ask everyone, how much you were willing to pay and subject you to the VCG mechanism. But imagine that Maury and Bart were friends and they both said, I'm willing to pay $1,000 to have it on this day rather than that day. Well, then we would definitely have it on that day. It would overwhelm everybody else's. But neither of them would pay anything. Because even without their report, because of the other one, it would have still gone that way, right? So because neither of them is individually pivotal, it's incredibly, incredibly susceptible to collusion. So these are two of many problems with the VCG mechanism, which make it fundamentally impractical. But what is quite practical is this basic insight that in VCG, these externalities are always going to look like these squares, right? We saw that here, these triangles, sorry. We saw that here, but that's a very general property. And basically the origin of QV was realizing that even though VCG makes no sense for these reasons I was just saying, that it always ends up looking like this thing that's a quadratic function of however much influence you have. Okay, let you guys out early today. Good luck on the problem set.
What if